So this is example number 3 for Helmholtz vortex theorem. In this particular theorem, we have a streamwise vortex. It's still a tube, but it's going streamwise instead of going perpendicular to the flow. And it was not expected. It got generated as we had the wind tunnel scenario, right? So you had the flow that it was generated in the wind tunnel, and this vortex was generated. And we want to know what is the average of the vorticity of the vortex generated in the test section. So before we move on, we have to understand what theorems I have to use. So first theorem that I know that I have to use is that I'm going to assume in my problem there's a uniform flow setting the chamber during the chamber. So in the setting chamber and the test section, the flow is completely uniform. So there's no turbulence, nothing happening here. Second thing that we're going to assume that two theorems specifically are going to apply. First one is going to say the vortex tube is going to remain a fluid tube. So here, this is going to be my vortex tube. Since moving across these lines, it's going to remain a fluid tube. And the third one, it says that my omega, my vorticity at any vorticity times the area, any location of my wind tunnel will remain constant. Okay, so if that was the case, then as a consequence of this one specifically, A1 over A2 is 10 over 1, because you can see that the area is 10, the area here is 1, and that gives you equal to 10. That's your R. And so you know that R at my test section, that would be R1 divided by R, and that would give me 20. Now that the problem says this is 20 divided by 10, so it gives me 1 over second, and that's the value that the problem is really asking for. Okay, so this will conclude example number 3.